Okay, so this is the screencast for myself, Cormac, and
myself, Patrick Reid, or Paddy,
for our MultiplayerCA3 assignment. So firstly, we're just going to do a quick overview of our client. So, Paddy, if you want to kick us off.
Yeah, so, well, we started out with the map tiles. So that was the first thing we really drew onto the game in the client. So the idea of the map tiles is that a game object is created for each tile. And then, so we'll start off. We'll go to the client here.
Yeah, so we use it using a text file to define how the map is laid out.
Yes, so we have our text file, which is stored in the assets folder. We bring it in, and we have two loops that reads each line of the text file. So it reads the top line, which is the X, and then it slowly travels down the Y, and each tile is initialized. Each number in the text file turns into a tile depending on the position of
the texture inside the
exactly.
inside the sprite sheet. So depending on the number specified in each box, it'll pick a different tile and it'll draw out the entire map for us.
Exactly. So for example, the tile map is 64 by 64, so that's one tile in the tile map. So we get the X position and we multiply it by.
We multiply it by 0.639.
Yeah.
Firstly, it's 0.64 because our zoom level is 100, so multiply that back. And then we found that it would result in like tiny gaps every now and again because of a percentage error that would be added onto each other. So if we made it 0.639, it was less likely that this would happen on the overlap. So,
yeah, exactly. So yeah, it's kind of what we figured out by just debugging and testing it. And that's.
Do you want to mention you attempting to do this from the server?
Yeah. So the first thing I did is the first thing I wanted to do, and the idea behind the tile map was that we have the server send it out to the clients. But the issue was the packet size, so we could only send something like 24 tiles when we wanted to render hundreds. So that idea was, we were unable to execute that idea, which resulted us going to the client and having each client draw their own map.
We would have liked to be able to have multiple maps on the server and the server been able to call it, but we kind of ran out of time there too. And the work involved in drawing a single map, Paddy can tell you.
Yeah, it's pretty time consuming. Especially if you have to edit the numbers in the text file afterwards and add zeros and take away commas, and numbers are not what they're supposed to be.
Do you want to open up the file?
Yeah, that's it. Sorry. Just ignore that. So, yeah.
So I'll just quickly go to the location. I can't actually remember. Where are we looking? Oh, it's in documents. Okay, so I'll just open this up. It's in assets.
Yeah. So we have 3 maps in here anyway. So there's my map, and thing. So the map we use for the final is this.
Go to it's layout. It'll make more sense if I turn off word wrap.
Okay, there you go. Yeah. So this is the world. 0 indicates the 0, 0 position in the tile sheet, which is the top left-hand corner, and then it takes 64 and 64 and renders that as a game object as a tile map. So here we have all the tile pieces, and in our for loop, the logic comes in where we can render the tiles. So
cool. So we'll just jump on and show some more stuff in the client.
Yeah, the client also has a duffel bag, which.
Yeah. So duffel bags, which are actually the mouse object we've kind of adapted, are spawned on the client. Now the server actually calls the spawning of them, but the mouse client has been adapted to function for these duffel bags that you pick up and drop off in drop-off points. The other thing that was added was a health pickup. Paddy added a health pickup, which is very similar, and when you collide with them, it gives you a boost in your health. And you can see the health client there. There's nothing much going on in there. It's a lot more code is happening.
Yeah, and another thing you can see there is the set scale function with the sprite sheet component. Is something we had to add because when you're actually rendering the textures in the render manager, I believe, or the sprite sheet render, the tile maps needed to be adjusted. So you needed to specify the scale of every piece. So when it renders, it gets the scale, and it renders it to its scale in where the tiles are being rendered in the client.
Yeah, the other thing in the client is the HUD. So depending on the game mode that's being set, it'll either render the game state stuff, so the game timer, the health, your current money, the scoreboard. But if it's not, it'll either render the win screen if the game is finished, or it'll render the lobby. So the HUD has been adapted to kind of work with this lobby manager. Now I'll come back to the lobby manager in just a bit for the server.
Yeah, the server decides which state you're on.
Yeah, actually we'll jump onto that right now. We'll just jump into an overview of the server, and the first thing we'll talk about the lobby system. So the majority of the lobby system logic is actually found in lobbymanager.cpp. So lobby manager is very similar to how the scoreboard manager in RoboCat works. And what it does is it creates a lobby player for each player that's joined, and this happens in server.cpp, if I'm not mistaken, on handle new client. Yeah, there we go, add entry. And this recognizes if a player is in the game, and it tracks if they're ready or not. So there's a boolean that each player can trigger using the space button. So if I jump into the input manager, you can see that's input state. Sorry, input manager is actually in client. Okay, so when a client hits the space key when the game is not playing, they will. Where is this down here? There we go. When they tap the space key when the game is not playing, it'll update the current player's ready state. So this variable is then set or checked in on the server side in RoboCat server. It's checked here, and it will actually call the lobby manager and tell the lobby manager to change the ready state of that player to whatever the current state of that player is ready. And what this ends up happening, there is on the HUD, it'll display. It would have been displaying the render lobby. The lobby manager logic will check all the players to see if they're ready or not, and if everyone is ready, then it'll trigger a timer to start, which is the time to game start timer, which lasts 15 seconds. And that there will start counting down, and when that finishes, it'll update the lobby state to be playing, and that's how this here switches to is game playing. So that's a very rough kind of way of describing the lobby. So simply, it's each player that joins is added to a list. The list is constantly checked to see if everyone is. It's checked to see if everyone's ready every time an update happens. If everyone is ready, it is checked once every second as the timer counts down to see if somebody changes their ready state or if somebody else joins, and it'll update accordingly. So that's pretty much the lobby state, the lobby system, and kind of feeds into the next thing that's happening on the server, which is the main game loop.
Yeah, so the main game loop, it's called in the doFrame function. That's RoboCat server, isn't it?
That's server.
Server, yeah. So we find the doFrame function. So in the doFrame function, here we set up the delta time, and then the delta time increases every time the frame gets called, the function gets called.
Time elapsed increases.
Yeah, so the time elapsed increases, and if the time elapsed hits 1, which is 1 second, it checks the state. So if the game is currently playing, it will check if the game timer is at 0. If the game timer is at 0, it'll reset the game. This is all happening in the lobby manager, and with the reset inside the reset function, we will also
So yeah,
quickly
when when the game starts and this loop is running, you'll find that the game is not playing, and it'll go into the else, and it'll see if everyone's ready, and it won't do anything until everyone's ready. Once everyone's ready, then it'll start decrementing the time to game start until it hits 0, and then it'll start the game. Once the game starts, then it gets into this loop.
Yeah, perfect. And then in this loop, once the timer hits 0 and the game resets, it'll quickly call a function in the lobby manager, which it'll set the end game state, which is the final screen. Yeah, it'll set the final screen to true, and it will print out end game and the player's manager, which the player who won the game, which has the highest. But we'll get into the gameplay later and display how that works.
Yeah, so that's pretty much an overview of the server. So just in general, discuss just kind of mention the protocol. So this we're using UDP for this project.
Yeah, so with UDP, we have more control over the packets that are sent, and it can be more efficient. The packets only send when we want them send them, which gives us a lot more room and stuff. Yeah, customization.
With UDP, we can we have to write our own custom way of handling packets, unlike with TCP. But it does allow that when when something changes, then it will send a packet. It's not sending a packet every frame, every tick, with useless information, and it means we can pack more into single packets, and we can be clever with how we pack them.
Yeah, which definitely allows for a smoother network with more people.
Yeah, and then just in general how it works here. So when a client connects, a welcome message is sent from the client to the server. The server then registers that there's a new client and keeps that information saved. So the next time the client talks to them, they know who they're talking to and they can talk back. The player, the lobby system, the scoreboard, pretty much all game objects, they're sent in packets, but only if they change. So there's if we go into the replication manager, there is a create, update, and destroy check, and this is where we decide, if we're actually writing, new updates to be sent from the server to the client. Something similar is happening in the client as well when it's sending to the back to the there it is there, to the server. So only when things change in any way is something sent. They're not sent else in any other case. So the server then handles, on top of this, it also handles changes such as collision detection and timers. This is good because if players are lagging because they have a bad internet connection, the collision detection isn't handling locally on their machine, or any physics simulation or timers where they might end up not being in sync. Handling it on the server makes sure that all players remain in sync and the game logic can function because of that. The clients clients that receive packets from the server will handle them, in their own way. But the main thing also is it can handle lost packets. If packets are dropped, then it'll be able to just kind of say, well, we'll wait till the next one, and we'll work it out the next time and adjust. So that's pretty much how that works. That's probably the end of part 1. We're probably going to jump into a part 2 video now. In a second.
Time's running out there, so move on then.